is where we're happy to address any questions you have about predictive analytics. You can think of this as our free consulting segment of the webinar. Open access to the modeling agency's advanced analytic gurus. That would be senior consultants Scott Terry and Keith McCormick. However, Keith is wrapping up a training event, and we knew that he'd had to head out early, so we called in another great TMA faculty to bring her vast experience to the Q&A, and I'd like to welcome TMA's newest faculty, Dr. Karima. Let's see if I can do this. I practiced this so much before the event. Diusicavina. So beyond having a long list of academic credentials, including a master's in engineering, an MBA, and a PhD in research and predictive modeling, Karima has extensive analytic team and project leadership experience, which of course is what's most attractive to the modeling agency. So I'd like to extend a warm welcome to Karima today. Let's test your mic and have you say hello.
Thank you, Eric. Can you hear me well?
Oh, loud and clear. Fantastic.
Yes,
great.
well,
Thanks, Karima. Good. And with such great resources in our event today, make sure to take advantage and enter your questions into the webinar panel. We have a few more coming in now. This is fantastic. Matter of fact, we may have close to enough to be very effective and efficient for the remainder of the event for the next 15 minutes. So any questions you have, you'll certainly receive specific compelling insights to help you on your way to gaining value out of predictive analytics, and I'll be pleased to read your questions aloud for Karima, Scott, or myself to respond. So let's start with a question from Prerna. Question is, what tools are used for cleaning the data? Since this goes back to, I think, closer to what Scott had presented, Scott wasn't specifically in data cleansing, but certainly data preparation. So going a little bit further upstream, we'll start with Scott and then we'll go over to Karima. Scott, what would you say are some tools used for cleaning the data? And feel free to reorient the question if you want to respond a little more strategically.
Well, that's an excellent question. Cleaning data is a big area of study, and cleaning can involve a whole lot of things such as data aggregation, outlier detection that we talked about, as well as missing values, duplication, householding data. There's a bunch of different tools that are available out there, but to be quite honest with you, I use the tool that I've got, and that's I work within a particular software environment, and I prefer to keep everything within that environment rather than switch from one tool to the next.
That's a good point. That was one of the favorite comments from our late Tony Rathburn, where people would ask him tool questions, and we'd remind them that we are vendor neutral and we don't showcase or disparage any tools. And at the same time, we do have a favorite tool, and that is the one that's already available. Start there. Karima, anything to add around tools for cleansing data?
When we are talking about cleansing data, probably it's, as Scott mentioned, is missing data as well as probably relevant attributes you want to choose and outliers, etc. So there are certainly different techniques to do that, and some of the popular ones probably which we're all using and I've been using quite often are statistical techniques, and these are the such as replacing the missing data by the means, medians, or expectation maximization. Certainly they are, these functions are embedded at many off-shelf software which are available even in SPSS. And it can go to more sophisticated techniques such as attribute selection, and these can be scheme specific, scheme independent. When we are talking about scheme specific, we can feed through our data through specific data mining techniques such as C4-5 for decision trees, and it will select for us relevant attributes. And certainly there are wrapper methods, etc. There are many technologies we can use for cleansing data.
Great advice. Thank you, Karima. And there's an extension to the question also from Prerna, and this might help understand the context around cleaning a little bit more. Prerna extends, I am building an automated model on predicting a student's scores based on his past results. I'm still in the process of how to go forth with it. Could you please suggest a starting point as well as mention a few free tools that I could make use of. So Karima, continuing with your discussion around cleansing, what is your advice around, for Prerna around the model building effort, and particularly how to get started?
Well, first of all, probably there is a need to identify what you are trying to do with your data. So what specifically is going to be derived from the analysis? Is it predictive analytics, or is it classification, or is it clustering, grouping them? If we are talking about classifications, then probably looking at the missing data, whether they belong to the attributes at the attribute level or to the class data, is the first point to go from. If there are missing data in the at the attribute levels, probably we wouldn't pay as much attention as to missing data at the class level, because we need that noise available when we are training a model. We need that noise available at the attribute data, because certainly we wouldn't train it on some clean data and apply it to some dirty data. But if you want to classify and there is some noise, some missing data at the class level, then we need to pay a specific attention. For instance, if it is persistent missing data of particular class of the students, if you are trying to analyze, for instance, whether they are likely to enroll or drop from the course or remain at the course, then attention needs to be spent whether it's a persistent missing value of a particular class. For instance, if there are more missing data for the students who are likely to enroll rather than dropping the course, then probably we will need to fill up that space. And it depends on the again, our target, our goal for data analysis. And there are different techniques taken from the statistics, such as we can replace it with the most likely outcome. In this case, if we are talking about discretional categorical data, if it's a binary class, for instance, whether they're going to enroll or drop, then probably we would look at the median of the data values which are most frequently, the mode which are most frequently present for a particular class value. Another method is also quite popular and taken from statistics are scheme independent, and we can put through our data the forward searching, backward searching, or bidirectional searching, and these statistical analyses are often embedded in the software that you are using. Depends on certainly which software you are using. So first of all, certainly looking for the missing data and relate it to your strategy, what you are going to do with your data. And second, as previously Scott already mentioned about missing data, you need to be careful. First of all, have you transformed your data enough to know whether these data are true outliers before you want to deal with them?
Sure. Yeah, that's a great answer, and thanks for all the detail and the great summary. Scott, how would you like to extend? Do you have a different perspective? Part of my curiosity is what is meant by automated. But what else would you like to? Yeah, I imagine that's where you'd have curiosity as well. And a lot of what Karima was relating was back to your data preparation and certainly working with missing data and outliers. But what additional advice do you have for Prerna?
Well, I think the short answer is to sign up for a course, because what we're really talking about is how to develop a model, and that takes a little bit more time than we've got in terms of available for this call. But what I would, and the reason why I would say it, I cringe a little bit when I hear the term automated modeling, is that modeling is a whole lot more than dumping data into an algorithm or software package and letting it whir and spin and spit out a magic answer on the other side. The software that we use, as well as the algorithms, are actually pretty stupid. They're just tools that we use, and the tool is no better than the person who's giving thought to how to use those tools. So backing up just a little bit, the most important thing that software can't automate nor understand nor even think about in terms of asking the question is, what is the problem that I'm trying to solve? That may sound like a simple question, but it could be answered a bunch of different ways. For example, if I'm trying to predict grades, am I trying to predict an A, B, C, D, or F? Or am I trying to predict a numeric grade, 97, 75, 64? When we think of it from those two possibilities, what we're talking about is two different types of problem approaches. The first one being, the numeric one being a numeric prediction, and the second one being a categorical prediction. If I were framing that problem, then the first thing I would try to do is I'd try to simplify the problem. The KISS principle and Occam's razor applies to modeling as well. If we're trying to predict an actual number, that's a much more difficult task than to predict a letter grade. So if I could frame the problem and reduce the complexity down to predicting a category, A, B, C, D, or F, then the likelihood that I'm going to succeed with my model is going to be increased, because not all modeling approaches are equally risky. Some are more risky than others. So if I could reduce the problem to a categorical prediction rather than numeric prediction, I'll be ahead of the game. So all of these are things that you learn in our courses that you probably don't learn in academia a whole lot, and it's a very important skill. It's part of the soft skills that a good data scientist needs. So I'd recommend that you sign up for the course. If somebody tries to sell you an automated modeling solution, I'd probably run really quick. To the last part of your question about software, the two leaders in terms of open software are R and Python. I think that's pretty much not in dispute. R is a more self-contained analytical environment. I think Python is becoming more popular because not only does it have all the analytical and modeling tools, but it's also a programming language that's extensible in a lot of other ways. So if you're developing systems, if you're trying to do web stuff, some people are tending to gravitate towards Python. So that's kind of a long-winded answer to a really good question. I would encourage you to sign up and get some education.
And Scott, I appreciate all of our self-serving promotions here, but it is completely legitimate advice, and I'd like to extend on that to say that not only can you not get that kind of training academically, but even commercially, the view that we have from an organizational standpoint, I'd like to respond a little bit further to Prerna's, even though we've got a couple of other questions here to wrap up with. I know we're going to go a little bit over, and we're happy to do so if you all will stick around with us from Jay Chung as well as Raj. We'll get to your questions in a moment. But with Prerna, some of the places where we're guarded have to do with what they call self-service analytics, and there are appropriate places for it. When IT makes data available more readily for users to be able to run their own searches and not have to be SQL experts, that's a very productive form of self-service analytics. And it's, they use that term analytics, but it's not the type of analytics that we all come to know. And so certainly any tools, particularly that talk about automated data preparation, gets into a very dangerous place. And you can see that from certainly Scott's portion of the presentation. And it goes one level higher, and this is where I wanted to, Prerna, offer some other advice with where to get started. And I'm going to go a little bit further upstream. And Scott had mentioned about understand, as well as Karima, about understanding the missing data, about how to transform it to be effective. And I'm going to go one layer higher, and that's to ensure that we address the so what question. And Scott was leading into that area where let's make sure we have our questions structured in a way that our algorithm is going to match and the way that we approach the analytics. And is it really the question that you or your leadership intend? And we find that a lot. We will work with leaders to back the question up a little bit and find that maybe there's a different orientation that's going to have a more productive purpose, where at first they may be saying, hey, I want to predict a grade for a student, but really what they want to predict is success. And so that begs for more types of data that may go beyond what's available. Can we look around for data enrichment? Is there sentiment data that's available? Is there other data that we can match up from, say, a data enrichment vendor that can be acquired that's going to have justifications for predictive value? And then how's it going to be reported? How's it going to be actionalized? Do we want to, maybe that's the part that you meant by automated, is that these results would drive a recruiting effort, and that's the automation of it, is how it's going to be actionalized. If not, who's going to use it? How do they want to interpret it? Is it going to be an executive dashboard that sets off certain warnings or monitors or recommendations? So those are the kind of things you want to ask before you start even diving into the data. Where was the data collected? How much can it be trusted? Just because there's some missing data doesn't necessarily mean that the rest is valid and can be trusted. So you want to talk to those who collected the data and any subject matter experts around how the grading occurs and what is our target at the end of the day for the analysis. Just knowing what a grade is going to be isn't necessarily going to predict whether a student is going to stay in the school, and it may be more of a retentive exercise. So ensuring that we have the questions set the right way is among the more important things to look at. It's almost like trying to win a car race. We find so many practitioners toiling under the hood to the extent of trying to get incremental value out of an analytic model and getting better R-squared or lower model error, as opposed to understanding what the real goals are and where the deployment's going to be. So at the end of the day, they end up with a better engine and a faster car, but they end up running off the track and going 45 degrees off course, yes, at a high rate of speed, but that doesn't help you when you're not driving toward the finish line. So, understanding the rules of the race, what it takes to win, that's what gets a trophy, not just having, a better engine. So that's something that we really impress upon practitioners to ensure that they are bringing value to their analytics, not just accuracy or impressive technical metrics. Let's go on to the next question, and it's from
excuse me, Eric.
Go ahead. Yeah, by all means.
If I can jump in real quick, I'd like to qualify the automated thing. There are certain processes, mainly ETL types of processes, that can be automated, as well as once you've developed a model, the application of the model in terms of scoring. So it's not an all or nothing type of thing. When I'm talking about automated is something you should avoid. I'm talking about actual model development. That's something that no software. I've been in this business a long time, and I've seen companies come and go with the promise of automated modeling, and every one of them fails. So the actual model development process is not something that today it can be automated. There are certain processes along the way that can be automated, but the modeling development process is something that you need to be involved with yourself. There's too much at stake usually.
Absolutely, yeah. From data preparation and transformation onto the model building itself, it really you've got to have the greater problem context in order to ensure that the results are valid and can be translated in terms that the organization will adopt and that is validated. So very important advice, and that's the kind of context that software simply can't take into consideration. That's the practitioner's job. So when you said automated, I'm trusting that you meant that once you've built your model using a valid process with all the aspects that we just described, that you can take those validated scores and perhaps drive, a student promotion kind of campaign for those that perform like the students that are your greatest winners or best performers. And that's why we always want to classify or clarify what is meant by automation and certainly self-service, because they do have their places, and they certainly have other places where you get into danger areas. Jay Chung asks, thanks for that extension. Scott, Jay Chung asks, could you speak more about failures in data transformation? Common mistakes, best practices, in what to check for, or examples, for example, cases of interest. I think Karima went first last time. Scott, let's go to you. This also pertains to your data transformation segment. If any part of it didn't make sense, let me know. I'll repeat.
Well, that's another really good question, Jay. I think the biggest failure, I'm kind of a big picture person who drills down. So in the big picture of failures in terms of data transformation is to not undertake it at all. Again, going back to the myth that a lot of people believe out when they're first coming into this industry is that you've got this super smart software that you dump data into and it knows what to do and it spits out a magic answer for you. That just doesn't happen. As a matter of fact, if you look at the modeling practice framework, most of the time, if you're doing it right, most of the time that'll be allotted to developing a model is going to be involved with data preparation, which includes data transformation. Within data transformation, again, it's a very wide type of subject. You've got algorithms that help you match. You may have a transaction database that has the same person on it 100 times. Well, do you want to count that as 100 different people, or do you want to try to identify that person based upon name and address and aggregate that data? On the other hand, if you look at their actual, for example, let's assume it's a business. If you want to look at their purchase transactions, if you aggregate the 100 people into one, how do you actually go about doing it? Certainly, you can add up all the transactions, but you may want to take it within a certain time period. Your time period needs to be appropriate for the objective that you've set. If you don't do your exploratories and look at your data in terms of how it graphs out, then a common transformation I'll use, for example, if I've got income kind of data. Income is usually a curve. It's usually a curve. If you're talking about age, as you're young, you have no income. As you get older, you peak at some point, and you start to decline in terms of your income, but your net worth may come up. So I look for nonlinear relationships. As a matter of fact, even though when you take statistics and you have these neat little curves and you have these neat little straight lines, very few things in life are straight lines. So the failure to look at each individual variable in terms of potential transforming it from one data scale to the next can get you in trouble. If you recall earlier in the presentation, I gave you an example of that.
Yes, you did, and that was fantastic. Scott, thanks very much for that. And we're almost 10 minutes over time. We've lost nobody, now that we started with a big group, but everybody is still fully attentive, and the questions continue to roll in. If nobody opposes, I can make sure that we address the remaining questions. There's just two more here, and but before we go on to them, Karima, you've not had a chance to extend, if you wanted to, for the data transformation question from Jay.
I think to add here, it again brings back to the goal of your data mining, and we need to remember that data mining, a significant part of data mining is also looking for interestingness, interesting patterns, and this is when we are looking for the anomalies, and these anomalies are often detected as outliers and can be erroneously removed because they are so far away from the main group. But these anomalies and these potentially to be considered outliers can actually carry a very interesting information which shouldn't be neglected. Depending on which industry you are working in, such an example could be brought from, for instance, zoology, when there is unusual behavior amongst the animals, but probably it's not very common to businesses. But in gardening businesses, there were cases when sellers were trying to grow a specific type of a flower, and they kept dying before they were able to actually collect them. And they assumed that this is the normal life cycle of the flowers, and they disregarded the extended lives of those flowers. Whereas if they paid attention to those outliers, they would notice that actually they kept dying because of inappropriate conditions they stored their flowers in, and that led to some proportion of loss in their profits, because they didn't notice the pattern, the interestingness in the behavior of the flowers. So you can certainly take a parallel to other businesses, and probably more common is in the fraud detection or some intervention in the IT work of information systems, when the anomalies are unfortunately often neglected. And again, also to summarize that before considering cleansing data, the data need to be properly transformed. For instance, when we are talking about outliers, one of the common mistakes probably you came across with it, that people, the analysts try to remove the outliers straight away, but other outliers will come up again over and over again because they've been masked by the previous outliers. So before removing the outliers that you are considering as such, transforming them, taking the logarithm of the data probably several times would bring to better results. So first of all, don't neglect outliers, don't neglect anomalies at all. First, consider from the perspectives of your goal of the data mining, and second, transform them properly.
Right. Yeah. Great advice. And Scott's presentation around 5 different options of how to treat outliers is brilliant, and it really comes down to that context that you need, particularly with predictive analytics, because in predictive analytics we're looking at those low occurrence, high impact transactions that can really pull a rookie, and sometimes those are the transactions of greatest interest. So again, working with your domain expert and the person who's closest to the data and understands how that data was collected and how much you can trust it, and what is the nature of the range of values that you have, and better understanding how each attribute was derived is going to help you to understand how to treat that data and how to transform it. You really need that context, and as Scott was saying, there's not software out there that can take into account the kinds of soft skills that you really need to understand that context, target the goals for the analytic endeavor, and express them in a way that's going to bring value to the organization. Great advice. So there was one quick question. I'm just going to toss this out there. You can mix this into your answer because there's 2 remaining questions. This one, I don't know that it's going to pertain to as many people, so I'm just going to cast it out there. If you want to include it in your response to the main next question, feel free to do so. But Raj asks, how successful is predictive modeling on streaming data? So that probably gets into kind of the IoT domain, and I know there was a lot of excitement around IoT, and I think it got tamped down to kind of an equal footing with any other data that you can collect. And again, you've got to assess it in the grand context of all other resources that you're going to bring to bear. Do those resources support stated objectives? What is the predictive value of each? What is the real-time essence that you've got to take into place? And do you need responses that fast? I've seen a lot of projects where there's been this emphasis on real-time, and at the end of the day, the information that needed to be drawn from the analysis didn't have to be real time. So you didn't have to take into account all of the other preparation that had to keep up with it. So let me keep that one as your side comment if you want to make it for the value of streaming data. Keep that in your back pocket when we respond to the next one. And you're welcome, Raj. I don't mean to gloss over the question, but we'll keep that out there for Karima and Scott to address if they wish as we wrap up on the last question. In terms of operationalization and strategy, is there a good typical makeup of the data analytics team, the number of roles and people and across data scientists, analysts, marketers, etc. You can divide these up in different ways. I'll take the first hack at this, then I'm going to yield. But we do have a couple of slides. One shows the primary roles, and one important thing to consider is that many times there are several people that will fulfill a single role on the analytic team, and then there are several roles that can be fulfilled by one person. But as Scott was saying, this is another topic we could spend hours on. Reason being, for each of these roles, there's different places where this role is going to have additional significance, and you saw that modeling practice framework. Let me give you one quick example, and then I'll go on to Karima and Scott. One example would be the role of the subject matter expert. There's places within the process that we need their particular contribution, and others where it can be detrimental. So typically the subject matter expert works more at the tails of the process. We need to interview, typically in the prepare phase, to understand, about the nature of the data, how it was collected, how much we can trust, the things we've talked about already, and then interpreting the model results. But if the subject matter expert is also the analyst, that can be a little bit dangerous, because sometimes they will bring preconceived notions into the analysis. They can feed bias into what should be an otherwise objective model. So we have, and this is something that Keith designed, what looks like a subway map, and it shows at any given place throughout the modeling practice framework, throughout development, where the different roles, from leadership to project management to data scientist or analytic practitioner to IT and BI to deploy, where they play specific functions for every task in the modeling practice framework. And there are junctions, there are milestones where these, the particular roles and players should meet and discuss, what's happening at any given point in the process. So hopefully that lets you know that there is a very coordinated way for an organizational team to function, and it does not start with data, it does not start with software, it does not start with algorithms. We've got to start upstream so that we understand how those results are going to be actionalized, how they're going to be measured, how they're going to be explained to leadership, how we're going to purpose those results, how we're going to evaluate the ultimate impact for the organization, so that we can adopt that process from the analytic endeavor. And when you do that, analytics is going to significantly advance your organization's value that they get from being data-driven. So I apologize for capitalizing that question. It's one that's close to my heart. Let me go ahead and offer up anything you'd like to say about streaming as well as the analytic team. Let's start with Karima this time.
Thank you, Eric. I completely agree with what Eric said about the participation, collective participation across the organization, because we need to remember again that data mining is mostly exercised as a tactical level or the functional level. However, we need first of all to plan which questions we are going to answer, so the right questions need to be asked before we are trying to answer them. And posing those questions, developing those questions depend very much on the people who have a helicopter view, a holistic picture of the business problem, and we call them modelers. So they would model those questions, model framework which will define the objectives for data miner, to which relevant attributes need to be collected, which data need to be collected. Because when we start analyzing from bottom-up level, when the data miner initiates the analysis, often it is not unusual that the data mining process is restricted to file mining, it is to the data that we have available in hand. And this does not exclude the problem which is called relying on false assumptions or neglecting very topical and emerging excuse me, issues which we have to consider. For instance, if a business wants to analyze why they are losing sales or losing customers, often what they would do, they would consider the marketing mix variables and incorporate them, maybe some operations, value chain analysis and supply chain analysis attributes would be related as well and analyzed. But what they often forget is about the macro environment, the environments that can be taken from the outside. And that bigger picture, the right questions can be again developed by the managers, by the people at the upper level. And that's why it's very important to work collaboratively and develop an overall picture to provide a better value to the data mining activity. About the streaming question Raj was asking, I think the value of analyzing streaming is cannot be is very good given that when we are using the streamlined data, we cannot use all of them, of course, because they are updated on a continuous basis and there are so many of them updated all the time. We certainly are using sampling, and that sampling is called pooling, when we are actually picking up the data which have been streamlined, and we are analyzing the sampling after sampling after sampling after sampling. And the beauty of it that we can use as many samples as there are, and that certainly provides us a better generalization. But again, this is not a significant prevalence to data that we are keeping in our warehouse. If what is most important is the approach, is the right techniques and the right questions to be asked and answered.
Excellent. Yes, that is, I like you underscoring that, Karima, and that's one of the things that we like to emphasize the most. Everyone thinks that the technology is the most sophisticated part, and, you know, from a technical perspective, maybe so, but that's not where most projects are missing, and that's not where we continue to do these face palms where, you know, it's really the design of the problem, and it's the, you know, ensuring the questions we want to ask are going to be answered from the way that we construct the project definition and the way that we go through to prepare the resources and translate the results. Those are far more impactful than you know, toiling over incremental accuracy. So as they say in a lot of these news shows, and Karima, thanks so much for your contributions. I know it's coming up on 11 p.m. UK time, so thanks for hanging in with us. And we still have 100%, still 100% retention here. Again, small group, but as we go more than 20 minutes overtime, as they say in the news industry, Scott, you get the last word.
Good. Okay. I'll try to be brief. To the streaming question, I believe the question had something to do with quality of predictive analytics as it relates to streaming. The answer to that is there is no answer to that. That's much like saying, you know, what does dessert taste like? Well, you know, when you ask somebody that question, they're gonna follow up with a bunch of different questions. Streaming, doing predictive analytics on streaming data is no better nor no worse than any other type of predictive analytics. It's dependent upon every other factor that creates successful predictive analytics for non-streaming data. So that's kind of the short answer. That you know, if it's not something that's black and white nor better or worse. It's just either successful or it isn't. In terms of the second question, you know, what I do is I take the modeling practice framework and I do an assessment. There's 4 or 5 things that you need to have a successful modeling practice. You need the commitment of senior leadership. You need a user base. You need technology in terms of software and hardware, and you need data. So I'd go through the modeling practice framework if I wanted to see, you know, what I needed for a team, and I'd make a list from the framework of those things that are important for predictive analytics. and then I'd do a gap analysis. I'd see what I've got available internally that could meet those needs, and then I'd see where I have a gap, and I'd look to see how I could close the gap either internally or by acquiring resources.
Great advice, and you're right. I mean, we certainly can't go over every detail of the modeling practice framework because, first of all, there's 7 phases. Then there's on average, about 10 objectives for each phase. Then each of those objectives have 2 to 8 tasks, and each of those tasks have several subtasks. So you can see how it becomes explosive in the number of tasks that you look at. But it's all there as a framework, and when you apply the framework, you'll find that some of the objectives don't even apply. So you can lop off that entire branch, but from the rest, you end up with this very specific kind of cookbook to put your process together of all the things that you do need to consider. And there's so many things that most analytic practitioners and data scientists overlook at their own peril, and a lot of that has to do with the culture of the organization. Some things you can change, others you can't. And isn't it good to know in advance the things that you can't instead of finding out after you've toiled over, a modeling effort that it was never going to be adopted? So, there's all sorts of things that need to be considered. We spell it all out. It's an expansion of the cross-industry standard framework, cross-industry standard CRISP DM, cross-industry standard. Help me out, Scott. Cross-industry standard.
For data, listen, Chris, cross-standard industry for, oh God, I forget it.
Cross-industry standard process.
Standard process for data mining.
There it is. Thank you, Karima. That's right. So that's at the core, and then we expanded it out because it really worked at the project level. But in reality, most organizations have to work at the project or practice level. And so it's all of our experience of how we work with leadership, how we work with the larger team to come up with all those kinds of strategic considerations that really impact whether the analytic effort is going to have value for the organization. So that's what we go through at the greatest detail that we can over a 5-day period. It's very comprehensive, but like I say, it's concentrated. That's what we convey in our class in order to be effective and purposeful and value-focused and goal-driven in your predictive analytics, the most we can pack in a 5-day orientation. So at nearly the top of the hour, extending our Q&A nearly a full 30 minutes, we better draw this event to a close. I'd certainly like to thank our very attentive, interactive attendees today for your sustained interest, your active participation, and certainly Scott and Keith for your great presentation segments and the highly informative Q&A driven by Karima and Scott. We'll follow up with an email shortly with some resources and suggestions that will hopefully be useful to you. From there, we'll hope that you'll consider joining us at a public classroom or live online training event soon. Make sure to go to the website and check out the schedule and details for our upcoming productions for the live online experiential courses in September and Washington, D.C. in October. On behalf of Scott, Keith, Karima, and myself, thank you again for attending Predictive Analytics Failure to Launch. Have a very pleasant afternoon, and for you, Karima, a very pleasant, very late evening. This brings the webinar broadcast to a close. You bet. Good night.
Thank you. Good evening.